Okay, now we're getting to the fun stuff. This is maybe new, although some of you guys did say yesterday that in 8th grade you may have learned about these trig functions. But if you ever looked at a calculator and wondered, like, there's a lot of buttons on here that I don't know what they do, we're going to learn 3 of them today. So follow along with this because we gotta kind of understand what in the world these trig functions, I call them trig functions, but trig ratios is what they also are, what they even are. So let's recall what we know about similar triangles from Unit 6. So we should know this. Similar triangles have angles that are what? But sides that are what? The angles are congruent, right? Angle, angle postulate, we needed congruent angles, but sides are proportional. So again, what this means is if I have 2 triangles that have all the same angles, they are guaranteed to be similar. And we can see that similarity through the proportions in the sides. So let's kind of refresh this here. Say we have this triangle over here. We know that we can find this missing angle here because how much is this angle? 90, right? We got 37, we got 90. Over here, we also have 37 and 90. So we can know what this last angle is going to be. Go ahead and find it real quick. We should know all 3 angles add up to 180. So what's that missing angle? Well, we've got 37 plus 90 is what we have so far. That's 127. Therefore, that last angle needs to get us the rest of the way to 180. So 180 minus 127 is going to be 53. So in both of these triangles, the angles are going to be the same because the angles always add up to 180. So these 2 triangles are similar. And notice we can see that to get from this shape over here, we divided each side by 2, right? 8 divided, that's a 2. 8 divided by 2 gets us to 4. 10 divided by 2 gets us to 5. 6 divided by 2 gets us to 3. So remember that that's what it means to be similar, right? I'm shrinking my shape down or making it bigger all by the same factor. Again, dividing by 2 here to get to this shape or multiplying by 2 to get to this shape. That's similarity. Now, something that ends up happening though actually is not only can we look at one shape to another and say, oh yeah, multiply by 2 to get from this shape to the next. We can also compare sides within each triangle and see that the ratio of the sides is going to be the same. So for example, if I chose to put 8 over 6, because these shapes are similar, this should equal the same thing as 4 over 3. So let's try that in our calculators. 8 divided by 6 gives us 1.33. And 4 divided by 3, gives us, hey, 1.33. So when 2 shapes are similar, I can actually compare 2 sides from one shape and 2 sides from another shape, and the ratios are actually the same. This would work out the exact same way. If I did 10 over 6 and 5 over 3, we'd get the same thing because these shapes are similar. Again, one is just a smaller version of the other, right? But the angles are all the same. Now, this is true for all triangles. What this means is that all triangles that have the same angles are similar to each other. So I could make a gazillion triangles with angles 37, 53, and 90, and these ratios come out to be the same. They're going to be similar. Every single triangle with angles 37, 53, and 90 are going to be similar. And that's true for all triangles. So we use that fact in trig ratios. So we're going to kind of build up to what the trig ratios are. So what trig ratios do is, again, they compare 2 sides of a right triangle in a fraction. Like we just did here, 8 and 6, we put it in a fraction. So this is what trig ratios do. Now, there's 3 different sides, obviously. What we do is we name them in respect to one of the acute angles. So C is the right angle here. So we only do trig ratios with the acute ones. So A and B are going to be the acute angles. You won't do a trig ratio with C. So we're going to name our sides in respect to A. So we have three sides that we're going to name. We have what we call the opposite side to A, the adjacent side, which if you guys can recall just means next to, and we have the hypotenuse. So the opposite side in respect to A is going to be through the triangle across from A. So watch how we go. So A here, little a, this side, is what we call the opposite. Here's angle A. Boom, there is the opposite side. Now, I typically actually name the hypotenuse next because the hypotenuse is a special side. We know what the hypotenuse is in any triangle regardless. Which of these three sides, we already got A as the opposite. So between B and C, which one's the hypotenuse? C is the hypotenuse because it is across from the right angle. It's the biggest side. Therefore, that leaves B to be the adjacent. And again, adjacent just means next to. So here's angle A. This side is next to angle A. Of course, the hypotenuse is next to angle A as well, but the hypotenuse is special. So basically, if you can name the opposite and the hypotenuse, the adjacent side is just the leftover side. Yeah. Now, we named those in respect to A, but I could also name them in respect to B, because now my opposite and my adjacents are going to be different. So try a moment. We have B, A, and C to name which is the opposite to B, the adjacent, and the hypotenuse. Let's try opposite first. Here's B. What side is opposite through the triangle to capital B? Little b. If I draw my little line here, boom, that is opposite to angle B. Now, the hypotenuse does not change because the hypotenuse is special, right? So C is still going to be the hypotenuse. So therefore now the adjacent in respect to B is A. Again, we can see this side is next to this angle, but it's not the hypotenuse. So we just call it the adjacent. We're going to have a lot more practice with this. That's a little bit confusing. We just want to keep that in mind. What we mean by in respect to. If I'm looking at A, what is opposite angle A is not what's opposite angle B. Keep that in mind. The perspective changes things. Okay. Oh, I meant to fill these in. Here are the three trig ratios. Now, again, if you have the notes packet, these are all of this stuff is there. You don't necessarily need to have it copied because this is all here at the top of the packet, but we still want to kind of follow along with it. So here are the three ratios. We have what's called sine, compares the opposite over the hypotenuse. So in a fraction, we're going to put the opposite side over the hypotenuse side. That's what that means. Cosine compares the adjacent over the hypotenuse, and tangent compares the opposite over the adjacent. Once again, if you have the packet, this is right here. You don't necessarily need to have this copy down. So we typically say, this is how it's spelled out, sine, cosine, tangent, but it's sin, cos, and tan is how we abbreviate it, and that's the buttons on the calculator. You see sin, cos, tan, but we say sine, cosine, and tangent. So the trig ratios for angle A is what we're going to say. So here's how you always write this. We have the trig function, and then the angle equals fraction. We're going to drill this in a bit more later. But sine equals the opposite over the hypotenuse. So I'm going to go ahead and say op over the hypotenuse. Cosine is the adjacent over the hypotenuse. So adjacent over the hypotenuse. And tangent is opposite over adjacent. So op over adjacent. So what we want to do to get these fractions is we want to label our triangle in respect to A. Now we just did this, but we're going to try it again. We need to say which of these three sides is the opposite, the adjacent, and the hypotenuse. Go ahead and think it through again, even though we just did it. Okay, so the opposite is going to be through my triangle. A is the opposite. Remember that this has to be the hypotenuse because that's special. Hypotenuse is always across from the right angle. Therefore, B has to be the adjacent. So all we have to do now is put these into our fractions. So if sine is opposite over hypotenuse, sine is going to be opposite over hypotenuse A over C. So there is our fraction for sine. Let's try cosine, and then I'm going to have you guys try tangent. So cosine is now the adjacent over the hypotenuse. So we labeled B to be the adjacent and C to be the hypotenuse. So go ahead and try for tangent now. Tangent is opposite over adjacent. What did we label the opposite? What did we label the adjacent? Okay, the opposite we labeled to be A, and adjacent we labeled to be B. So there we go. There is our trig ratios that are comparing those different sides. So we're going to erase this, and I want you guys to try it again. Now for angle B, we need to look at, this is now our perspective. So now that this is our perspective, what's the opposite, what's the adjacent, what's the hypotenuse? And then go ahead and get your three functions. I'll go ahead and write them in to start with. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Once again, because our perspective has changed and now we're looking at B, that's going to change what we consider the opposite and the adjacent. Go ahead and give it a try. Try and get those three based off our picture here. Okay, so B, little b, is now the opposite. Again, I'm looking differently now. So based on this perspective, that's the opposite side. C is still the hypotenuse because the hypotenuse doesn't change. A is now the adjacent. So hopefully you can understand when we change the angles we're looking at, the opposite and the adjacent just switch. So we should have gotten opposite over hypotenuse, B over C. We should have gotten adjacent over hypotenuse, A over C. And for tangent, we should have had opposite over adjacent, B over A. Again, we're going to drill this in a bit more. You have this in the packet. It's all right there. But we still want to talk through, make sure we understand what. Now, how in the world are we supposed to remember all these ratios? Yes, you have your notes. Normally, in a normal year, you wouldn't. And so it's like, how in the world do you remember all of this? Well, there is a handy-dandy mnemonic device, kind of like PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction, to help you remember the order of operations. It is called Sokatoa, the mighty and powerful trig volcano. It's not an actual volcano, but Sokatoa just sounds like a volcano. There's actually a volcano called Krakatoa. If you guys have watched SpongeBob, I think Squidward sometimes says Krakatoa. It's actually a volcano. So Sokatoa is the mnemonic device, which just is a way for you to remember which sides go with which trig function. So this is not in the notes packet, so I'd recommend to write this down. Now, we see it like this. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. However, I write it like this typically. Sine is opposite over hypotenuse because we see sine separately from its fraction versus just seeing it like this. We can go, oh, okay, sine, there's its fraction. Cosine, there's its fraction. Tangent, there's its fraction. So I'm going to be writing it like this so we can see very clearly S, C, and T are the trig ratios, and here are their fractions. Now, it's really silly, guys. Again, you have your notes, but if you want to memorize this, you have to know how it's spelled. It's pronounced Sokatoa. I have had kids, because they don't understand how to spell it, they can say Sokatoa, and then they spell it like this. They'd spell So-ka, and they go Toa. That's not Toa, that's just toe, right? T-O-H. This is Toa. This is Ka, A. This is So, H. Or sorry, O. Yeah, so it sounds silly, but if you spell it wrong, you get the wrong sides. So, Ka for A, Toa, O-A. Okay, but again, you're going to have your notes. I'd recommend definitely write that whenever you do these problems, though, so you don't have to flip through your notes every single time. You want to write that at the top of every page you're doing for trig. So we're going to try one quick example. I know this has been a bit of a longer video, but I really want to explain where these trig functions come from. A lot of teachers will be like, here, trig functions. And you're like, what? Why are these the way that they are? So we want to have that understanding. So what we're going to do here is we are going to do the sine, cosine, and tangent ratios just like we did here for each acute angle in the right triangle. So the acute angles are once again going to be x and z. Y is the right the right angle. So we're not going to do the trig ratios for that one. Is it open? Okay. Yeah, you're good. I can edit it. Okay. Okay. So we're going to have sine of x, cosine of x, that's how we say this, and tangent of x equals. So to start with, let's go ahead and let's label our sides. We have xy equals 3. Oh, and guys, sorry, if you have the packet, this is example 1 in the packet. Xy equals 3, y, x, what? Whoops, sorry, I typed this wrong. YZ, there we go. YZ equals 4 and XZ equals 5. So what we're going to do, again, we know Sokatoa. We are going to first step label our sides in respect to x, and then we can get our fractions from there. So start off, do it right on your picture. In respect to x, which is the opposite, which is the adjacent, which is the hypotenuse, go ahead and try it. Okay, so the opposite is through the triangle. Again, that's really important. Opposite is away from. So this is the opposite side. 5 has to be the hypotenuse. That's the side across from the right angle. Therefore, 3 has to be the adjacent. So we have opposite over hypotenuse. We have adjacent over hypotenuse. We have over a. I'm going to give you a moment. If you weren't able to get the fractions, go ahead and try it. We're just popping the numbers in where they should go. So we need opposite over hypotenuse. That is 4 over 5. And there's our answer. We're going to work with this again much more in class. We just want to get these fractions first. We have adjacent over hypotenuse is 3 over 5. And tangent, we have opposite over adjacent. That's going to be 4 over 3. So these are our fractions in respect to x. You guys are going to try it one more time now in respect to z. So you should have sine z, cosine z, and tangent z. So we need to relabel our sides. You might want to erase your labels you had before because now the opposite and the adjacent are changing because now z is our perspective. So opposite across from z is going to be different than what's across from x. But go ahead and try it. The whole thing, get your fractions, label your side, and then we'll check. Okay, so once again, this is still 3, 4, and 5. I hope you didn't switch those. That doesn't change. What changes is that now 3 is the opposite across from z. 5 is still the hypotenuse, and 4 is now the adjacent. So we should have had sine is once again opposite of our hypotenuse. That's so. We have 3 is the opposite now. Over 5 is the hypotenuse. Cosine, that's ka from Sokatoa. We've got the adjacent over the hypotenuse. The adjacent is now 4. Hypotenuse is still 5. And lastly, tangent is opposite over adjacent, O over A. This is now 3 over 4. So again, in class, we're going to talk about why this matters and how we're going to even use this. But we really have to be strong with, okay, sine is opposite over adjacent. Opposite over hypotenuse. Here's my opposite. Here's my hypotenuse. Boom, there's my fraction. We got to be really strong with that before we can move on.